Hey everyone, this week we're going to start talking about beams. In this module, beams are going to be the heart of everything that we analyze, both external and internal forces. Now beams are all around us, obviously, and by that we're referring to the horizontal members of a building structure. I'm over here on West Campus, and behind me you can see this awning structure. Several large beams make that up, and again, the horizontal members there. Now those beams, in this case, made out of steel, and they've got several loads on them. And what we're going to learn how to do this week is to take those beams and analyze the forces on them and figure out what the internal forces are. And we're going to look at what is called shear and moment and analyze those forces internally. As we study these beams, I want to point out there's going to be some terminology that we're going to use in terms of how the beams are supported. If you can look at that large horizontal beam behind me, you'll notice that it's supported on the ends, or nearly the ends, by two columns. That kind of scenario is going to be referred to as a simply supported beam. Let's take a look at another type of support for a beam. Take a look at that window awning or window covering behind me, that steel structure that sticks out from the building. You'll notice there's a horizontal component to that. That's a beam. And that beam has that slanted or angled portion that it actually acts as the window covering. Well, the horizontal portion is a beam, and it's what we refer to as a cantilever beam. The way it's supported is in a cantilever fashion. That beam actually extends into the building. We don't see it, but it has to, because otherwise the weight of that window cover would cause the beam to come down. So it must be supported inside the building. Cantilever beams are supported on one end and not the other. It's another example of a loading scenario.
Now that you've seen a couple of different ways in which beams are supported, let's draw those. The first one that I'm going to draw would be the simply supported beam. In this case, we have our horizontal member, the beam itself, and that is supported by columns on each end. Now I'm going to draw those columns in a free body diagram form. Forces acting upward, we could call them reaction A and reaction B. But the main thing for the simply supported beam configuration is that you have their supports on the ends of the beam. Of course, there may be loads due to weight or mechanical equipment like air conditioners, that kind of thing. You may have a distributed load that would be due to, say, snow on the end or something along those lines. You could also have a cantilever scenario. And in a cantilever scenario, the beam is held only on one end. It is in this case that we have an upward force on one end. Now we also have to have a reaction of a moment. Otherwise, the beam would fall on the right end. So we have this moment that tends to rotate it back. And that is due or caused by the beam being inside a building, for example, embedded in the concrete. Of course, we can have loads as well, and we call that a cantilever beam. You can have a combination of these two in what's called an overhanging beam. And it would look something like this. And one of the supports on the end, the other support not on the end, a combination of both. Now with this information, we can move forward and start looking at the internal bending moment and shear inside the beams.